We're on page 18. And again, the whole point of today is looking at equations that have roots in other versions than what we've already seen. We saw the ones where we FOIL, we get one or two answers, we plug them in to see if they're both good, and we check for extraneous things. A couple of variations that we need to look at. The first one is what happens if we have a rational exponent in there. So for example, like letter A, halfway down on the page. 3 times x plus 1 to the 2/3 equals 2. Any idea what we would probably do first in letter A? Divide by 3. Step number 1 is going to be get the piece with the rational exponent by itself. Let me write that as a first step, and then we'll go do that in letter A. Step number 1. Get the piece with the rational exponent by itself. Just like before, when our direction was get the root by itself, same idea here. Step number 1, we're going to get the piece with the rational exponent by itself. So Jacob said divide both sides by 3 in letter A. That's exactly what I'm going to do. Divide by 3. Divide by 3. We're going to get x plus 1 to the 2/3 equals 4. Now is going to be a little bit different. I could rewrite this with roots and powers and all that stuff, but there's going to be an easier way to deal with this. First of all, a 2/3 power means what root and what power? Cube root, second power, and all that stuff. What I can do instead is I can raise both sides to the reciprocal power. We're going to write this down, then I'm going to show you why that's going to work. Step number 2, raise both sides. Raise both sides to the reciprocal power. Please stop. We're going to raise both sides to the reciprocal power. If my power is 2/3, what's the reciprocal? 3/3. Not opposite reciprocal, not like perpendicular things, just truly the reciprocal, flip it. So I've got x plus 1 to the 2/3. I'm just going to write it as a separate line so you kind of see the progression in the work. And I'm going to raise that side to the 3/2. And on the other side, well, if you raise one side to the 3/2, I've got to raise the other side to the 3/2. This would be really good to write down. Okay, I didn't notice that. Here's the point. On the left side, I get x plus 1 raised to the, when you do power to a power, what do you do to them? Add them, multiply them? Multiply. What's 2/3 times 3/2? 6/6, which is 1. We were able to cancel out that power. That was the whole point of that. On the other side, well, we need to do the problem 4 to the 3/2. Square root of 4, and when you're done, do what to it? Cube it. Let me write that down. I'm doing the square root of 4, and then I'm going to cube it. So what is it? It's 8. You're going to get x plus 1 equals 8. Step number 3, just solve. However, when you're done, what extra step do you think we're probably going to have to do? Any of these, because of just how roots work, could create extraneous solutions, so we will have to check for them. Step 3 in the process is going to be solve the much easier equation that you get and check for extraneous solutions. Solve and check for extraneous solutions. It needs to be close enough. I need to know what you're trying to say. Plus, the directions are probably going to say solve and check for extraneous solutions, so you could look there and copy from there. So I already heard someone say subtract 1. Sure, that's what we're going to do. And I'm going to get x equals 7, maybe. Then we need to go back to the original. We need to check, and we need to do 3 times 7 plus 1 to the 2/3 maybe equals 12. Well, 7 plus 1 is 8, so 3 times 8 to the 2/3. No, so the plugging in check truly is just plug it in and then order of operations. You're thinking solving work, which is different. 8 to the 2/3. 4. Cube root of 8 is 2. Squared gives us 4. Write that out if you need to. Cube root of 8. So we're 3 times 8 to the 2/3 equals 12. Do you see where I got that line from? Okay, we need to do 8 to the 2/3, which means cube root of 8. Square it. Cube root of 8 is 2. Squared gives us 4. 3 times 4 equals 12. Yes, it does. That works. So the one answer I got was good. Otherwise, you'd have no solution, and what you got would be extraneous. Bless you. The point is, get the piece with the power by itself. Raise both sides to the reciprocal power. So in letter B, once you get things by itself, what power are you going to raise both sides to? 5/3. I want to see if you can do letter B. Very similar idea to letter A. See what you can do. No, because I want them to try the problem. So if you're watching at home, try the problem now. You too. You here in person, try the problem. What? Oh, didn't I say that a couple times?
What?
Okay, right now, go solve. Worry about that right now.
Where was the permission slip for you to record?
It's really just supposed to be picking up me. You, by talking, end up on solve. Go do things.
Secretly record.
Go do things, Aiden. Oh my gosh.
Yeah, they said this was supposed to be fun. We're having fun. I'm having fun.
If you use a calculator, yeah, that's fine, I guess.
25 over 3? Really? Leave it like that?
Oh, it shouldn't be 25 over 3. I think you need to get rid of the plus 1 first,
Oh, so it's 24.
which will be something good.
I don't know. I have to do it by 5 first.
So I was able to get x plus 1 to the 3/5 equals 8. Could you turn it into that? What's our next step? I have not solved anything yet. So do what, Ben? Raise both sides to the 5/3. So I'm going to raise the left to the 5/3, the right to 5/3. I'm going to get x plus 1 equals. Please stop throwing things. How do I do 8 to the 5/3? Cube root of 8 to the 5th. What's the cube root of 8? 2 to the 5th? 32. We're going to get x plus 1. X plus 1 equals 32. Subtract 1 from both sides, and your possible solution should be x equals 31. Then we need to plug it in to make sure it actually works. Please stop. There's no reason for you to be turning around. We're going to get 3 times 31 plus 1 to the 3/5. Plus 1, I want to see if that ends up equaling 25. 31 plus 1 is 32. And 32 to the 3/5, well, the 5th root of 32 is 2. Cubed gives me 8, so 3 times 8 plus 1 maybe equals 25. Yes, 25 equals 25. So the one answer we got is a valid solution. There will be maybe 2 or 3 of these types of equations in the homework. And when we have a quiz on this stuff, you'll have 1 with the fraction power. Monday with this stuff. All the equations. 1 with the fraction powers. There will be other all the other types of equations we've been seeing, but just one of this particular type.
More than one section.
It'll also be some graphing, but that's going to be easy stuff we'll do tomorrow. It'll mostly be equations. We'll talk more about that tomorrow. Next type of equation. Equations that have two roots in them. So we are on page 19. There are two types of equations that have two roots. One type is very easy, and one type is as tough as they're going to get. The one on the top, I'm not even going to give you directions. What do you think you would do? Not square root both sides, but do it. And then solve, and when you're done, what should you do? Check. There is nothing special in that top equation. Square both sides, and go. I'm getting 2 for my possible answer. Again, we're not done. We've got to make sure it's actually a valid solution. For my check, I'm going to do the square root of 4 times 2 plus 2 may be equals square root of 3 times 2 plus 4. 8 plus 2 square root of 10 may be equals square root of 10. Yeah, it does. We're good. 2 was my valid answer. Make sure you're saying 2 is the answer. They're not root 10. That was the check thing. But 2 is the answer that made both sides work. There will be like 1 or 2 of these in the homework. This is not a big deal. This is not really what the two root stuff is all about. The next one is much more difficult. What else do you have in that problem that's in the box? Sure, but there was a square root. There were 2 roots over here. There are 2 roots over here. There's actually one really small, easy-looking thing that's going to make this a lot harder. Sure, but I could always move one thing to the other side. Let me do that. Let me go move that root x to the other side. And I'm going to go do plus root x plus root x. And I'm going to get the square root of 2x plus 1 equals square root of x plus 1. And actually, why don't I start writing down the process? Step number 1 is going to be get one of the roots by itself. Get one of the roots by itself. It was easiest here just to add the square root of x to both sides, although I suppose if you wanted to do more work, you could have gotten rid of the other root, whatever. Here's the problem. Is it going to be easy to square the left? Sure, you just get 2x plus 1. Why is it not as easy to square the right, Edie? What in that problem tells you there's going to be foiling? The addition. It's not just a root by itself. Because there's a plus 1, it's going to make this way more involved. Step number 2. We need to square both sides, and I'm going to say in parentheses, foiling when necessary. Don't start doing the work yet because we need to be a little careful how the foiling is going to work. Step number 2. Square both sides. Foiling when necessary. So, square root 2x plus 1 equals square root of x plus 1. I'm just going to show that as a separate line, so when you're looking back in the notes, you see this is my next step. I'm going to square both sides. Left is really easy. But the right, to square that thing, I'm going to need to write the thing out twice. So root x plus 1 times root x plus 1. Please focus. Now, I'm going to get 2x plus 1. When I do root x times root x, I'm going to get x. It's like saying, what's root x squared? It's just x. If you don't like that, you could also say the square root of x squared. Are we okay? I could also say the square root of x squared, but square root of x squared is just x, so I'm going to skip over that step. Next, square root of x times 1 gives me the square root of x. 1 times the square root of x gives me another square root of x. And 1 times 1 gives me 1. When we're done with this, I should combine like terms on that side. So I'm going to get 2x plus 1 equals x plus 2 root x plus 1. What's the problem? There's still a root. Before, I was basically able to get rid of the root with just one step. I did some squaring, and my roots were all gone. I still have a root left. How do I get rid of a root? Square. Can I do that right now? Step number 3. We're going to get the remaining root by itself, sort of. And then we're going to square both sides. I'll explain the sort of in a moment. We're going to get the remaining root by itself, and square both sides. So, I need to get rid of the x. I need to get rid of the 1. I'm going to subtract x and subtract 1 from both sides. I'll just do that at the same time. I'm going to get just x, which is kind of nice on that side, which means no foiling, equals 2 root x. Now, I could divide by 2, but if I do, I'm going to get like 1/2 x. And there's actually a way I can deal with this that then won't have the fractions. I think I'm going to stop getting the root by itself with this step. And I'm going to go and I'm going to square both sides. I'm just going to rewrite it. So hold on a minute. Again, if I did divide by 2, then I'd get some fractions, and I'd love to avoid fractions. I'm going to leave it, and you'll see what happens when I leave it. On the left side, x squared is x squared. Now on the right side, I want to square this 2 root x thing. All that means is you square the 2, you square the root x, and you multiply those answers. 4 times x. Square the 2, you get 4. Square root x, you get x. Not 4 plus x, but 4 times x. No fractions. That's nice. I know it looks a little weird, but it's a quadratic equation, so what I want it to equal 0. I might as well write step 4 now. We're just going to say solve and check. I'm going to subtract 4x. 4x, not 4x, x squared minus 4x equals 0. What do we do to solve this? Oh, don't complete the square. That would be painful. GCF. Always look for a GCF. There is one here, and that's all the factoring you have to do. You're going to get x times x minus 4. So what are your two possibilities? 0 and 4. I'd like you to do the last step. Go back to the original before any squaring happened that had the 2 roots in it. Plug in your 0, plug in your 4. Let's see if they're both good. This is definitely the hardest type of these problems. We're going to do another one completely together before I give you a couple to try on your own. There will be just 2 of these in the homework, just 1 of this type on a quiz, and just 1 on the test, because these are the toughest type. Do your checking and finish this off. That's why there's only going to be 1. Please stop talking and do the plugging and check. And if you're already done, then please just sit quietly. Is 0 good? Yeah, it should give you the problem 1 minus 0 equals 1. That's okay. Is 4 good? As I mentioned last time when we did this stuff, sometimes there will be 2 good answers, sometimes only 1 and 1's extraneous, sometimes neither one's good, but in this case, both 0 and 4 were valid solutions. Make sure you show the plugging in check, though. I need to see how you're plugging in to basically prove to me that, yes, 1 equals 1, or 1 equals 2, so no, you know that's not correct, and things like that. The good news with these tough problems that have 2 roots and require us to square things twice is it will be the same process every time. There's just lots of little places things can go wrong, so they're a little tricky. But it's not like we're going to have to use some new logic or something in different types of problems. Let's look at 20, and I want to do a lot of this work together. Oh, but they're fraction powers. Oh, but they're good fraction powers. What does it really mean? They're just square roots. So let's not actually solve the problem that's given to us. Let's solve this one instead. If it was a fraction power with something other than like a 1 in the numerator, that's when I would do the reciprocal thing. Plus, we only dealt with those that had 1 of those. 1/2 power just means square root. Do what first? Which one do you want to move? Yeah, I would much rather get rid of the one that's being subtracted because then I don't have to deal with minus signs anywhere here. I'm going to go and add root 3x minus 2 to both sides. Root x plus 3 equals negative 1 plus root 3x minus 2. I guess you could put the root first. Doesn't really matter. I want to do the squaring part with you. So I'm going to square both sides. The left is really easy. Left is x plus 3. Square of square root, they cancel. On the right, I'm going to write it out twice. How many of you put the negative 1 first? Do the rest of you put the root first? Okay, then I'm just going to switch the order just to make it match what most people have. I'm going to say root 3x minus 2 minus 1 times root 3x minus 2 minus 1. Okay, root 3x minus 2 times root 3x minus 2. What was that? Okay, if I was actually going to multiply the stuff underneath the roots, I'd have to multiply 3x minus 2 by 3x minus 2, which means FOIL, and I don't want to do that. I'm multiplying a root by itself, which is like squaring a square root. What does it become? Mara? Just 3x minus 2. Yeah, we've canceled out our roots. 3x minus 2. Next, root 3x minus 2 times minus 1 will give us minus root 3x minus 2. You're going to get that again when you do negative 1 times root 3x minus 2, negative root 3x minus 2, and you'll end with a plus 1. And I want you to take a moment and just combine like terms on that side. Minus 1 of these things, minus 1 of those things. How many of those things do you have? Plus or minus? Negative 1 of those things, minus another 1 of those things, negative 2 of those things. Minus 2, root 3x minus 2 is what that'll become. I've got x plus 3 here. 3x is already good. Negative 2 plus 1 gives me negative 1. And then minus 2, root 3x minus 2. I'm going to go and move the 3x minus 1 to the other side. So minus 3x plus 1 and minus 3x plus 1. Negative 2x plus 4 equals negative 2 root 3x minus 2. Okay, could I divide both sides by negative 2 and not get fractions? I could. Only to show you what happens when I have something like this, I think I want to keep it and not divide, just so you see how to deal with things where there's the negative 2 and then a more complicated root like this. But you certainly, in this problem, could divide both sides by negative 2. I'm going to leave it, though, and I'm going to square both sides. On the left, that means write it out twice and FOIL. So negative 2x plus 4 times negative 2x plus 4. The right. Square negative 2. 4. Square that square root. What do you get? You like what I wrote?
No.
What do I need to do? You need to show that it's multiplication. It was a multiplication problem. It is still a multiplication. I did that because that's a common mistake that I'm used to seeing from people. It was multiplication. It's got to stay multiplication because you're going to need to distribute the 4. You take a moment, do your foiling, do your distributing, and then stop. Please be really careful with your signs. I saw some weird sign things on the midterm. What's negative 2x times negative 2x? Positive 4x squared, yeah. So I'm getting 4x squared minus 16x plus 16 equals 2x minus 8. Make it equal 0.
You can show both of themselves.
Absolutely. Four x squared minus 28x plus 24 equals 0. And I need to solve. Is there a GCF? Always look for a GCF because it's going to make your factoring a whole lot easier. Never complete the square with these. Factoring or quadratic formula, although the problems I'm going to give you should all be factorable at some point. So look for a GCF first. There is one. I'm going to take out that 4 and get x squared minus 7x plus 6 equals 0, which is kind of nice. 4 times x minus 6, x minus 1. What are your possible answers? Does the 4 give you anything? No. So it's like we set all the parts equal to 0. Set x minus 1 equal to 0, you get 1. X minus 6 equal to 0, we get 6. Set 4 equal to 0, there's nothing to solve there. That's not a true statement. We're not going to get anything from there. 4x up front would be different, but I don't have that here. I'm almost set. Not negative 1. 6 and 1 are the two possibilities. Now what? Check them. Please go back to the original, or if you don't want the original with the 1/2 in there, you can use the original with the roots in there. It's the same thing. Plug them in and check. I'm pretty sure at least one is not going to be good. Maybe both aren't good, but at least one is going to have an issue.
There's no such easier way to check that.
Not for these types. We're going to see other equations in the next 2 units with extraneous solutions that has a shortcut check, but with the roots, the only way is by actually plugging it in. This is easy math. This stuff is hard. Plugging in a number should be easy.
It's not easy. It's just a lot of time.
But you've got to prove to me, though, that it works. So I've got to see what the numbers end up being. Please stop talking. Please stop talking.
You have to show the second one.
I need to see the plugging and check. You need to prove to me that this one actually works or this one doesn't work.
That's just allows the roots. I mean, like this one.
No, you could go back to the original with the 1/2 power. I would just rather.
I mean, like, you know, the second line.
Well, I kind of need to see what I really need is the third line that I haven't done
So
yet.
you don't have to put that.
Show me some numbers with things. Is 6 good? Yeah, I'm getting 3 minus 4 equals -1. That is true, so 6 is good. Is 1 good? 2 minus 1 equals -1. No, it doesn't. 1 does not equal -1. So you're going to write your answer as x equals 6, and then 1 is extraneous. They will not be harder than the second one we just did. I would like you to take out a piece of paper or grab some paper from the side, and I want to do just 2 more problems that we're gonna try. One with the fraction power for you to try on your own, and then one with these 2 roots to see what you can do, because we kind of did both of these together. Grab some paper quickly from the side. Have a seat, please, Johnny. Don't cause trouble. Okay. First problem, I would like you to solve and check. Let's deal with 2 times x plus 5 to the 3/4 minus 14 equals 40. Please go solve and check. Please have a seat. This one shouldn't take too long, and we'll do one more and we'll be set for today. If you do need to go back to this in your notes, I think this was page 18 in the notes. Please wait till Spencer gets back. I don't know, but please wait till he gets back. Have a seat, please. You should have x plus 5 to the 3/4 equals 27 as one of your lines. What do I do? Not really multiply, but raise both sides to that power. It means we'll multiply our powers, but really I'm raising both sides to the 4/3. So what do I get on the left? Just x plus 5. Excuse me. On the right side, what am I going to do? 81, cube root of 27, if you need to write that out. And then we're going to raise that to the 4th. We'll get 81. Subtract 5 from both sides. We should have 76. And then just go do the plugging and check. To the 3/4. Yeah, 4th root of 81 is 3. Cubed gives us 27, so I want to do 2 times 27 minus 14. That's going to work. 54 minus 14, yes, gives us 40. So it was good. We're going to try a 2 root 1. There are going to be 2 of these in the homework. You have a whole page to do the work. If I see like 2 lines of work, that's not going to count for credit for those, because that means you didn't actually use the process we talked about. I would recommend having your notes open to page 20, so you kind of have a model in front of you. And I would like to see what you can do, maybe checking in with someone near you. I'd like to see what you can do in this one. Square root of x plus 3 plus square root of 2 minus x equals 3. See what you can do. I'll be like a minute or 2 behind you with the work, so you can get some work and then you can check my work and see what you can do. Again, this is as hard as they're going to get. Right now, I would like you to try to solve that. Use the notes we just took and see what you can do, please. And again, page 20 in the notes would have that example similar to this one. I guess it becomes a little different because you're going to have a minus that you're going to end up squaring. But as long as we're careful with the signs, everything will work out. Looking for someone in here? Hi.
Can I see Mr. Colitis in the hallway?
Did you guys put the 3 first or the root first? Okay, then I guess I'll switch things. Doesn't really matter. You'll still get the same final answer. Which actually means we should be a little bit careful with something. Are you down to this line? When you multiply this negative root by this negative root, you get a positive answer or a negative? Positive. And then, so what is root 2 minus x times root 2 minus x? Just 2 minus x. Keep going with the rest. There shouldn't be anything strange in the rest of it. I would really suggest doing the problem. I see a lot of you just sitting there right now. That's not really going to help so much. Right, that's not what we're supposed to be doing right now. No. I would keep it at home because some of the stuff will still keep coming back on cumulative reviews because we're going to need those ideas for other units. But you can take it out of the binder. Again, I would like you solving this equation right now. Are you okay with the x plus 3 equals 11 minus x minus 6 root 2 minus x?
No, so you have to,
Well, do you have that line?
yeah.
Okay, so then I'm going to add x to both sides and subtract 11 from both sides so I can get this root by itself. Not until you have the other root by itself. So that's going to be my next step, absolutely. But not until I have this root as it is. Otherwise, you'd have to FOIL that with 3. That's going to be ugly with 3. And it won't get rid of the root. That's the problem. If you're not going to do the problem, then at least just sit quietly. When you go to solve, remember GCF first, and then it'll be something much easier that you can factor. And of course, when you're done, make sure you do that plugging and check. I'm getting -2 and -1 is the positive 1 is the possibilities. I'm seeing some nodding from a couple people. Yes, Mara, Edie. Good. So then I'm going to plug them in. Let me just do this over here. Square root of -2 plus 3 plus square root of 2 minus -2 maybe equals 3. Square root of 1 plus 3 plus square root of 2 minus 1 maybe equals 3. And they should both be good. They should both be valid solutions. All the check stuff worked there.